Three.
Yeah. So today we will learn about how RV all-in-one ARM microcontroller has been designed, how to work with the kit, how to conduct the different experiments using the kits. Let's start learn about the kit. So this is the kit given to you. Now you can just open the kit and just slide the kit to open the door. So then keep it aside. Then once you have the kit, there are two portions are there in the kit. So the first one is called as the CPU board LPC2148. The second one is called as an application board. So let's learn about the CPU board first. What all the facilities we have in the CPU board. This is the ARM LPC2148 microcontroller. So 64-pin IC that will be supplied with what is called as a crystal of 12 megahertz. So this is a crystal which is connected to the LPC2148, and this LPC2148 can be programmed with a lot of peripheral components which are surrounded that one. Let's learn what are the components present around that one. So we have the 5 application keys are available. These keys are connected to the LPC2148 general purpose IO pins. So the first key is a little special key. It's called as a programmable key. So we will learn later how to use this key to download a program into the LPC2148. Now, the second output interface what we are given in the application board is a LCD. This LCD is a 4-line LCD. So we can program this 4-line LCD using the LPC2148. Now, after that, now we will go to the other interfaces. We have what is called as one LED we given for testing your purpose. This is called as D7 LCD. This is the D7 LCD LED. A single LED is there which is connected to P0.31, which can be used for testing your board is working or the program is working. It's like a testing LED. Then you have an RGB LED is there. So you can able to program this LED to displaying multiple colors, millions of colors, using 3 pins which are controlled by the PWM channels of the LPC2148. Then we have a buzzer. So this is connected to the DAC output of the LPC2148. You can produce variety of sounds and music using this buzzer. Then we have what is called as the interfaces which are used to connect to the other devices like a computer, laptop, and to the cloud. What are the serial interfaces we have provided in the board? So number one, we have provided what is called UART interface. So RXT, TXT in the ground, which can be used to connect to the other computers like Raspberry Pi or even Arduino board or the computer using this interface. The same UART interface is provided using what is called RS-232 standard. So wherever your computer has got RS-232 port, you can directly connect this port to the computer RS-232 port. Now, apart from these two, we have 2 Wi-Fi communication methods are provided in the board. Through that, you can connect to the cloud or internet. One is the Bluetooth module is provided on the board. The other is the Wi-Fi module, ESP8266 module is also plugged in the board. Now for storage, there are 2 types of storage we can able to do it. Below this LCD, we have provided what is called as battery backed up RTC, so that the time, the date, important passwords I can store in the RTC backed up, the cell which is there below here. These cells are capable to work 3-4 years even without any replacement. That means that any important information during the program development you can store in the RTC backed up RAM, which is provided below this one. The cell is also provided below this LCD. Next, if you have a large storage required, the file system you have to implement, you can use what is called as an SD card. SD card interface is also provided using the SPA protocol of the LPC2148. Now, so apart from this one, we also provided a USB device interface, so which is used for data transfer from a computer to this board, and also for programming we'll be using that one. So this is about what is called as the application board. This is called as CPU board. So this CPU board is connected to an application board. How they have connected? We have brought all the pins of the LPC2148 GPU pins, the power lines, other things on a 80-pin Burr connector. So through this connector, we have interfaced to this application board. Now, application board provides lot of interfaces to build lot of projects, including the robotic projects. Let's learn about the application board. What are the facilities it provides? The first interface provided by the application board is the logic controller. We have 8 LEDs here and the 8 switches are available here, so that I can write a program to read the switches and implement the logic controller using these LEDs. The second interface provided by the application board is 7-segment display. The 5 7-segment digits are there. They are being driven through the shift registers, which are in turn supplied by or controlled by the LPC2148 provided on the CPU board. Now, apart from the 7-segment display, we have lot of types of motors can be controlled using this board. What are the different types of motors? I can control this one. So the stepper motors are of two types available. One is called bipolar and a unipolar. Bipolar motors, you can have a very small steps like a micro stepping. You can divide 1.8 degree into smaller steps. So if you have a bipolar stepper motors, use the connectors, the first and the second connectors. We have noted there bipolar 1, bipolar 2. So the related circuits has been integrated into this chip. Now, if you have a normal stepper motor like 1.8 degree step angle, so you can always use what is called unipolar. The next two connectors are available for the stepper motor, unipolar stepper motors. So in the lab experiment, we are using the unipolar stepper motor. Connect to the third connector from the right side. So if I start there from this counting from 1, 2, 3, here is a place where you connect your stepper motor. Now, apart from the unipolar stepper motor, we have the connection for a DC motor. So you can connect the DC motor here and you can control the speed of the DC motor using the LPC2148. The next two connectors are provided for the servo motors. So here you can connect the servo motors and you can use those servo motors in building robotic applications. Many times when we want to build a robotic application, we require x-axis control and a y-axis control. So in such cases, x home position and a y home position or can be read as a sensor inputs into these points. So these are the 2 points for robotic applications. Now we will understand what are the other interfaces provided. These are called sensor interfaces. What are the sensor interfaces? I have it. Number one, I can read the LDR. I can connect a light sensor directly to this point, LDR, so that I can able to measure the light intensity of which is falling on the LDR. So all these sensors outputs are connected to the analog inputs of LPC2148. Now let's go to the second interface provided for the sensor. It's a LM35. The temperature sensor can be connected to this point. I can measure the temperature and display on the any one of the output gadgets here. The next is a general purpose external sensor input. So any sensor which you want to connect, which has got analog output, can be connected to this one, so that we can able to use this third connector to measure any sensor in general. So and measure the digital equivalent of that analog input using the LPC2148. Now, so we have provided two interfaces for what is called as reading the digital sensors. We know that digital sensors will give what is called as logic 1 or 0, but they are not in the TTL. So they may be in the range of 0 to 10 volts. In such cases, we require an opto isolator to read the digital sensors. So the two inputs are provided